So if you have a second order differential equation y double dash plus p of x y dash plus q of x y equals to 0, then this if p of x and q of x are analytic at the point x equals to x naught. So this is that it is analytic at point centered. Basically analytic means centered at the point x equal to 0. So analytic means defined. So analytic means defined, and these, if the p of x and q of x are analytic at the point x equals to x naught, that means defined in at the x naught, x equals to x naught, then these points are called ordinary points. If p of x and q of x are like p of x naught and q of x naught are defined, so these points are known as an ordinary points. And the points at which p of x and q of x are not analytic, not analytic means that it is not defined, then these points defined at a specific point centered, if it is centered at x equals to x naught, then, or you can say that if the denominator is equal, denominator makes it a 0 or vanishes, then those points are called singular points. So you have to focus only the singular points, then the rest of the points means that these functions p of x and q of x are always defined at those points, and the rest of the points are naturally called as ordinary points. So this is all about specific points or singular points and ordinary points of the second order differential equation. So it is all concerned about p of x and q of x. So here equation is x square into y double dash plus 3 into x y dash plus x plus 1 into y equals to 0. And the second example is, we will come to it later on. So first is this. So first step is that we have to convert it into the standard form. For standard form, you have to divide it with the leading coefficient. Here leading coefficient function is x square minus 1. So if you divide this equation with the x square minus 1, then it becomes 3x divided by x square minus 1 to y dash plus x plus 1 divided by x square minus 1 into y equals to 0. So here is the p of x and this is the q of x. You can also solve it further. That makes it y double dash plus 3 of x, x square minus 1 y dash plus, if you use the formula x plus 1 and x minus 1, then it will be y divided by x minus 1 equals to 0. So your singular points are where your denominator vanishes or where your denominator is equal to 0. So here is the this term will give you the singular points. So singular points is either it is undefined or either this denominator equals to 0. So that rises to the fact x equals to plus minus 1. So plus minus 1 are the singular points, and all the rest of the points are called ordinary points, and the ordinary points are from minus infinity to minus 1, union from minus 1 to plus 1, and union from plus 1 to plus 1 to infinity. So this is these are your ordinary points. Okay. Now we come to our next example number 2, and that is already in the standard form, y double dash plus cos of x into y dash plus e to the power x into y equals to 0. So cos of x and q of x is e to the power x. One is a trigonometric function and the other is exponential function, and I cannot find any point in the cos of x function that gives rise to the fact that denominator is equal to 0. and or denominator is equal to 0, or where p of x is undefined or q of x is undefined. So it is everywhere it is defined. So all points from minus infinity to plus infinity are the ordinary points, and there is no one specific point that will give this function an undefined answer. So no singular point. In simple, you can say that there is no singular point in this example. Okay, and in the third example is you have to solve it with your own self. This is a second order with the help of power series. Second order differential equation, y double dash minus x into y minus y equals to 0. You have to solve it re-indexing and further. And one more thing you have to take in your mind, that is that if you will take its second derivative, then this index starts from the n equals to 2. First derivative starts from n equals to 1, and then your second derivative starts from n equals to 2, and then you have to re-index the first derivative and second derivative accordingly with the help of a new variable, and you call it as a dummy variable. Have you done this example by your own self for the sake of your practice or not? So thank you so much if you have understood this. If you have any queries, we can discuss it later on in the online class.